My dear friends, I, kapil, welcomes to all of you in our educational platform. My dear friends, in the previous lecture, we have already learned about intervals, right? That there are four kind of intervals. With use of that intervals, we may derive any kind of elements of set R. Now today, we are going to start our name of the chapter, linear inequalities. In this chapter, we have to learn about inequalities. Right? What is inequality? For example, I say 8 and 5. Then you know that 8 and 5 are not equal. It means unequal, not equal. But what the relation between them? Then you can say that 8 is more than 5. So yes, 8 is more than 5 is the relation between 8 and 5. Okay, what is relation between 5 and 8? You can say that 5 is less than 8. So these are relation between these two numbers. So any two real numbers expressed with the symbol greater than or less than, then it represents as inequality. So first basic thing about inequality is this: two real numbers can be expressed with the symbol. Here the symbol are this, with the symbol less than, greater than, less than or equal to, or greater or equal to, known as not equality. Not equality. Not equality means inequality. This not equality means inequality. See, 8 and 5. Then we may say that 8 is more than 5. So any two real numbers you can select. Sometimes variable is also there. So any two real number or variable we just write with the help of this symbolical representation, less than, greater than, less than or equal to, greater or equal to, that is known as inequality. For example, 8 is greater than 5 as we discussed here. This is first inequality. Or one more example I just write in the variable form, x is less than or equal to 7. What the meaning of this? X is the real number, which is either 7 or less than 7. So x is either 7 or less than 7, right? So this is the meaning of this inequality. It means this kind of inequality we have to learn. But our first topic is what about linear inequality? Now linear inequality is what? Let us see. But before we define linear inequality, let us think about linear equation. In standard times you learned about linear equation very well, right? So I think you know that. Suppose this kind of linear equation you already solved. 7x plus 3y equals to 2. You know that this is linear equation in two variables. Which two variables are assigned here? One is x and one is y. A linear equality equation equality given. This is linear equation 7x plus 3y is 2. It means here you have to put the value of x and y such that the equation is 2. It means the answer of 7x plus 3y must be 2. It's known as equation or equality is there. But this equality is in two variables. And now I write equality in one variable. See here. 3x minus 6 is 0. How many variables are there? See, only one variable is x. There are two variables. So this is linear equation in two variables. Here there is only one variable x. So it's known as linear equation in one variable. Now how can we find the solution? So nothing to do, just the 6 is going on that side. We may write 3x equals to 6. Minus 6 going on that side positive. And what about x from it? Then we may say that x equals to 2. So x equals to 2 is the solution of this linear equation in one variable. Now just think about that. Suppose I write 3x minus 6 greater than 0. Inequality. Suppose now this is not balanced equation. Suppose inequality, it means I write this 4 symbol and one symbol out of them. So I use the symbol greater than. It means 3x minus 6 greater than 0. Now what? Now calculation is saying minus 6 is going on that side. Then we may write 3x is greater than 6. Again x is greater than 6 by 3 and therefore x is greater than 2c. This is the solution of this linear inequality in one variable. Now in your mind the question arises. Question is this: what the solution is? It means when we solve with help of this mathematical calculation, we get the result x is greater than 2. But what the meaning of this x greater than 2? It's very easy. Now we know that derive it on number line. That's why in previous lecture we had learned this number line. X is greater than 2 means 2 is here somewhere. Here is 1, here is 0, you know about that. There is 3, 4, 5 and so on. Greater than 2 means this all the portion greater than 2. These values are less than 2. These values are greater. So this is our solution. It means that when we solve linear inequality, we didn't get any fixed solution. We get here infinitely many solutions. It means solution set. So we have a solution set when we solve linear inequality. Okay? So now what is the general form of linear inequality? X plus b is either greater than 0 or less than 0 or greater or equal than 0 and so on. So let us derive linear inequality in one variable. So our new topic is linear inequality in one variable. Let us see. Linear inequality in one variable. So let us write the variable as x. Now you know that general equation I just write. And inequality ax plus b. See here, there are 4 different values: greater than, less than, greater or equal, or less than or equal. 0. See here, there is 3x minus 6 is equals to 0, equality. Here is inequality. A means 3, b means minus 6. Every linear equation is of the form x plus b is 0. But inequality, that's why either x plus b is greater than 0 or less than 0 or greater or equal than 0 or less than or equal to 0. So all 4 types of inequality I write in this roof, right, in one roof. So in inequality x plus b is this is known as linear inequality in one variable. Linear inequality in one variable. Right? And solution. Remember that solution is here solution set. Solution of the inequality is always in the form of solution set. So which can be solvable? Which can be solvable? In set n, z or r as listing method. It means as a set, as a solution set. So remember that here solution, as we decide here, what the solution see for this inequality, the solution set is, we may say that the solution set is we may say that 2 to infinite c. As we discussed that 2 is not including hollow circle, to infinite here, so 2 to infinite is the solution of this linear inequality. So this linear inequality may helps to solve. Now let us discuss results on inequality. Results on inequality are very important. Let us start with the first result. If A is greater than B, then we may say that A plus C is also greater than B plus C. It means if A is greater than B is given, then we add C on both sides, then A plus C is also greater than B plus C. For example, I just said that, for example in general, we know that 8 is greater than 6, right? Then add C. See here, what the meaning is this? 8 is A, 6 is B. Now add any value C. For example, I add 2 here, then 8 plus 2 greater than 6 plus 2. It means add any number C on both sides, then inequality remains as it is. It means inequality does not change. Second case. Now similarly we may say that if A is greater than B is given, then A minus C is also greater than B minus C. Again we give the same example. For example here 8 is greater than 6, then let us subtract 2 on both sides. Subtraction, do you know that? 8 minus 2, then obviously greater than 6 minus 2. It means here C means 2, A means 8 and B means 6. So this is A, this is B, here is A minus C and here is B minus C. So see the relation is confirmed, right? So in the case of addition or subtraction, my just topic is this: when you add or subtract any real number from the inequality, inequality remains as it is. Now the third thing is this: if A greater than B, then my dear friends, when you multiply with negative sign, your inequality will be changed. Apart you free inequality must be changed. See why? The reason is very easy. For example, okay, now I just give the same example. 8 greater than 6, confirmed? 8 greater than 6, but multiply it with negative sign. What we say? You know very well that minus 8 is now less than minus 6. Is it clear? When we multiply with negative sign, it is very obvious that inequality must be changed. Fourth and important result and last result. If A greater than B, then my dear friends, 1 by A must be less than 1 by B. It means when we take reciprocal, then what we say? Inequality must be changed. Okay? So let us see one example. For example, again, now I just give the example like this. 4 is greater than 2. Do you know that? Yes, 4 is greater than 2. Then what we may say that 1 by 4 is less than 1 by 2. Okay? 1 by 4. See, when I take reciprocal, what happened? 1 by 4 means 0.25. And we know that now 0.25 is less than 0.5. So these 4 results are very useful. I repeat once again. What actually the main thing is this? When inequality is given and if you multiply with negative sign, inequality will be changed. When inequality is given and you take reciprocal, in that case also inequality must be changed. So with the help of these results, let us start or let us solve the questions related to your first exercise. So let us solve your first exercise, exercise 6.1. And let's start one example from this. Exercise 6.1. Example number 1. First example, let us solve. Example is this. Solve 24x is less than 100. Solve 24x less than 100, where x is belongs to n, it means natural number, that after axis belongs to z. It means where x is natural number and here x is integer and x belongs to z. Okay, moreover, let us take x belongs to r also. So I just take and x belongs to r as per our convenience. Okay, let us try to solve this one. 24x less than 100. Then you get confident that how to solve the questions. Very easy exercise is this. See here, 24x is less than 100 is given. So here we start with given expression 24x less than 100. First of all, this 24 is going on that side. What do we get? X is less than 100 by 24. 100 by 24. I think you know that. 24 4s are 96. Right? 4 is there and 0 is there. 24 1s are 24 and you know that 16 and 0. That means 8 and something is there. So I think it will be approximately 4.18 like this. 4.18 or 17 something. So x is less than 4.17 and so on, right? And now how can we decide that? What about the solution for this kind of set? Now let us draw the number line again. X is less than 4.17. Exactly 4.17 is where? Let us see by using this number line. In this number line, we know that here somewhere is 0, here is minus infinite and here is plus infinite with help of number line. Now here is 1, 2, 3, 4 and 4.17 is here somewhere. See, this is the point which is 4.17. It means this is the value of 100 by 24. Right? 4.17. 4.17 just approximately I write there. Now less than 4.17. Less than means our solution must be here. See, less than. X is less than 4.7. It means less than 100 by 24. Here all the values are there. So as we know from theoretical result, we have to derive here dark line to represent it. So let us derive a dark line and also here is hollow circle to deriving this 4.17. Here somewhere is 4. So what the solution set in n? See, first of all, if x belongs to n, then here remember that. What about the solution in n? You know that here is 1, 2, 3 and 4. Here is minus 1, minus 2, minus 3, minus 4 and so on, right? These are integers there. Remember that our solution is in n, that after n. So if x belongs to n, then solution set is, or solution is, we may say that 1, 2, 3 and 4. See here the meaning. X is less than 4.17. So less than 4.17, all natural number is our solution. All natural numbers. So how many natural number less than 4.17 in this number line? Natural number only. 1, 2, 3, 4. And if x belongs to z, then I think you can say that solution is here. All this integers start from that. And here we may start minus 3, minus 2, minus 1, 0. See here it represents all negative integers 0. That after 1, 2, 3 and 4 also. So this is solution in Z. And finally if x belongs to R, then the solution is, what is the solution? See here. You can say that minus infinite to 100 by 24 open. Both sides open. Okay, so both sides open is the answer. So finally, minus infinite to 100 by 24 open interval is the answer, right? So this is the end of the example. Similarly, you can solve yourself example number 2, 3 and 4. So try to solve this example yourself. Otherwise, we will discuss it in the next lecture. Till then, goodbye.